Good morning, students. This is your maths teacher Santosh Kumar, and today we are going to see the topic called inverse of a matrix. How to find out inverse of a matrix by elementary transformation. Okay, so now by elementary transformation, right? The first elementary transformation is row I and row j. Row I and row j you can interchange. There are 6 elementary transformations, right? Later on you will be able to understand what is mean by elementary transformation. It's like a formula. Okay, it's an operation that we can apply on matrices. Fine. So one is Ri tends to Rj and Rj tends to Ri. That means you can interchange any two rows, that is row 1 and row 2, you can interchange in the matrix. It is allowed, okay, while finding the inverse of a matrix, which is allowed. So row I and row j you can interchange. Say for example row 1 and row 3 you can interchange it. So the next one is second elementary transformation, which is Ri. Any one particular row you can multiply by a constant, that is Ri you can multiply by the constant k, and those values you can put in again in Ri. Say for example row 1 you can multiply by a constant k, and you can put the values in the again same row I itself. Over here k is a constant. K can be any number or any element, but k should not be 0, so k is not equal to 0. And the elementary operation third elementary operation is any one particular row, that is any Ri tends to Ri plus k times Rj. Ri tends to okay, that is Ri tends to Ri plus k times Rj. The meaning of this one is any one particular row, that is row 2, you can multiply by the constant, and that you can add with the row I, right? So the whole value you can put it in row I itself. This I'll explain you, right? Most of the time we use this elementary transformation to make one particular row as 0. Okay, and this one we will use mostly to make one on the particular number, on the particular element we will make it as 1. So for that purpose we will use this one. There is any one element you can, if you want to make it as 1, we will use this one. Okay, and similarly for making zeros, right, we use this elementary transformation. And the first one, Ri tends to Ri, Ri tends to Rj, and Rj tends to Ri, which is used for what? Interchanging the two rows, so that it will make your operations as easy. It will make easier way to find out the inverse of a matrix. Okay, so now how to use this one is, what is the procedure to find out the inverse of a matrix, we are going to see now. Okay, say for example you take any matrix, 1 2 cross 2 matrix. I'll take matrix A is equal to which is 2 5 1 and 3. Okay, now you see how I'm going to find out inverse of this matrix. Okay, very easy. You will be able to understand by using the elementary operations, elementary transformations. You have to find the inverse of a matrix. Fine. Now you see the given matrix, you can write it as A is equal to IA. A is equal to IA you can write, because any matrix if you multiply with I, you are going to get the same thing. So you can write any matrix as A is equal to IA. For example, if you want, you can see this example. 1 0 0 1 is the identity matrix, and this matrix with 1 and 1 5 and 1. If you multiply these two matrices, what will happen? Row into column, so it becomes 1. Again row into column, it will become 5 plus 0 5. You multiply this row and this column, so 0, and this one will become 1. And then this row into this column. If you multiply, you get again 0 into 5 is 0 and 1 into 1 is 1, so 1. You see now, any matrix, this matrix you multiplied with this one and you are getting the same thing, correct? Now these two are same, so matrix A you can write it as I into A. Fine, it is like 1 element 1, right? Exactly, to say it is like an element 1 in the numbers, right? In the numbers how we see 1. Likewise in matrix in matrix unit matrix, that is this one, identity matrix is 1. Fine. Then now what you have to do is put the matrix A here. A is 2 5 1 3 and I is identity matrix of order 2, so 1 0 0 1, and A is as it is you put. Okay, now what you do, this matrix, so what is the operation is, this matrix you have to make it as identity matrix by using these three provision, right? These three elementary transformations you have to use to make this matrix as identity matrix, and whatever the transformation you are using over here, the same has to be applied over here also. Okay, so now you see, I'm going to make this as identity matrix. What is meant by identity matrix? You just write here what is meant by identity matrix, which is 1 0 0 1 for 2 cross 2, right? So my first element over here, it should be 1, so I have to make this element as 1 to form this as identity matrix, correct? Understood? So now interchange these two rows, because I want to make this element as 1. So if I interchange these two rows by using the first property, first transformation, okay, so I am going to interchange R1 in sending to R2 and R2 sending to R1. So this one I can shift over here, so 1 and 3 and 2 and 5 here. Are you able to understand? Okay, next, so whatever the operation I am doing over here, the same thing I have to apply over here also, so do it. So 0 1 over here, and this 1 and 0 will come down. Okay, now so I made 1 here. Next you can make this element as 0, okay, because you have to form identity matrix. So this element as 0, for 0 special transformation, I told you this is mostly we used to make what, no, 0. So I'm going to apply that. This element, if I want to make 0, what I'm going to do, that element present in row 2, correct? So you have to start with row 2. You look at the transformation, Ri tends to Ri, you have to write first. So row 2 tends to row 2, correct? Plus K over here, what is that? K into Rj. So what do you do? Corresponding element for this one in the first row is what? No, this one. That element you have to make it as -2, and if you add with this one, it becomes 0, correct? So what I'm doing, this one's a corresponding row element in the first row is this one, that you multiply by -2, then only this element will become -2, that is -2 times R1. So row 2 tends to row 2 -2 times R1, correct? That, I mean, what you are doing, this you are multiplying by -2, and if you add with this one, what will happen? The answer will be 0, correct? So row 2 tends to row 2 -2 times row 1, that is I am using the third property, third transformation. So what you do, whenever you want to make a problem in a easy method, for which row you didn't apply any property, right? That row you first fill it. So as it is 1 and 3, I didn't apply anything, so you have to fill it 0 and 1 over here. Now multiplying this row element by -2 and add with corresponding row elements in row 2. Fine. So multiply by -2 and add with this one 0. Multiply by -2 and add with this one. If you multiply by this by -2, what will happen? -6. And add with this one, you get -1. Am I correct? Then multiply this by same thing, same operation you have to do over here. Okay. So this element you multiply by -2 and add with this one, you get 1. And this element you multiply by -2 and add with this one, you will get again 1 only. Correct? Sorry. If you multiply this element by -2 and if you add with this one, -2 you get. Okay. So now what you do, what is your aim? You need to make identity matrix, correct? So what you do, this element you make it as 1. Sir, how to make it as 1? If you ask me, it's very easy. You see property 2. Property 2 is actually special for making 1. Okay, so what is the property 2? Ri tends to k times Ri. That means any one particular row you can multiply by a constant, but the constant should not be 0. Okay, so to make this as 1, what I'm going to do, I'm going to make this row element, this row fully, that is, it is present in row 2. So row 2 tends to minus 1 time row 2. Okay, so that means this row fully, if I multiply by minus, then this minus 1 will become plus. Okay, so first row I am not going to apply any property, so I am writing as it is 1, 3 and 0, 1. And this row, if you multiply by minus 1, this will become 0, this will become plus 1, this will become minus 1, and this will become plus 2, correct? Okay, now you need to make this 3 as 1, then only you can make identity matrix here. Okay, so can you do that? What operation you will make to make 0? To make 0, you know, which is third transformation you have to use, correct? So what I'm going to do, this element I'm going to make it as 0, right? So it is present in row 1. So row 1 tends to row 1, you have to write. Then corresponding element, row element for 3 is this one, that is in row 2, correct? So row 2 you can put, but row 2 is only 1. If you make this as minus 3 and if you add with this one, it becomes 0, correct? So you have to multiply this by minus 3. So row 1 tends to row 1 minus 3 times row 2. Okay, so next step is you have to apply it. Okay, and which row you didn't apply any property? The second row, because for the first row only you are changing. So second row will be as it is. You can ask your doubts also. Okay, you too. And so second row as it is I am keeping. So 0 and 1 as it is I am keeping, and the over here the second row as it is 1, minus 1 and 2. And now, so what are you doing? Yeah, now you see row 1. So next step what we have to do is we need to make this 3 as what now? This 3 as 0 you have to make. For making 0, we have to use the third property. The third property is over here, Ri tends to Ri plus k times Rj. The meaning of this one is any row you can multiply by a constant and add with the existing row, one particular row. Okay, so and you can, the final answer you can put it in the same row. So my plan is now, our plan is 3. This 3 you need to make it as 0. So to make this 3 as 0, what we have to do is I'm going to apply this, that the 3 present in row 1. So row 1 tends to row 1, and then corresponding row element for this 3 is this 1. So you have to make this 1 as minus 3. So with that 1, what will you multiply to make this as minus 3? Yeah, yes. So you have to multiply by minus 3. So this, if you multiply by minus 3 and adding with this one, it makes 0. So 3 present in row 1 minus that 1 present in row 2. So minus 3 times row 2. Fine. So now I'm going to do the next step. The next step is for which row we didn't apply the property for the second row. So second row you have to fill it as it is. Second row 0 and 1 is as it is, and minus 1 and 2 is as it is. Now for the first row, what we applied here is, what we planned here is second row we have to multiply by minus 3 and add with this one. So multiplying this by minus 3 and adding with this one is 1, and multiplying this by minus 3 and adding with this one will become 0, and multiplying this by minus 3 and adding with this one is going to be 3. Multiply this by minus 3, so it becomes minus 6, and adding with this one it becomes minus 5, correct? Now you see product of two matrices, value is 1. that, right? Product of two matrices, answer is identity matrix you are getting. That means A's inverse is the matrix which you got over here is nothing but the A inverse. So 3 into 3 and minus 5 and minus 1 and 2. So this is the inverse of A. Sir, how do you say it is the inverse of A? If you ask me, you just imagine here. For numbers you take. For numbers 2 into some number is equal to 1 means what will you put here? 2 into some number value is 1 means what will you put here? So 2 into some number is equal to 1. What will you put here? I'm asking. That is 1 by 2, correct? So then only it will become 1. So 2 into this 1 by 2 you can write it as 2's inverse. Correct? So product of two number gives 1 means then inverse for 2 is 2 inverse and inverse for 1 by 2 is 2. So same thing we are applying over here. Product of two matrices. Value is identity matrix. Correct? It is like identity matrix is like 1. Now the product of these two is 1. So A's inverse is this one only, no. So A's inverse is this one. Correct? Because the product gives 1. 1 is nothing here in matrices like 1. What is there in the matrix is identity matrix. So any two matrices if you multiply and if you get identity matrix, then the matrices which are over here, one we call it as for A's inverse is this one and this matrix inverse is that one. Okay, suppose here if you want any confusion, if you are having any confusion, or else if you want to check the whether the answer is correct or not, if you want to check, then you can go with this one also. What is that? Which is A and A inverse. Both if you multiply, your answer will be I. You can check it. Suppose if you want to check the answer, where A is nothing but what? 2 and 5 and 1 and 3, where A inverse is what you found, which is 3 and minus 5, and then which is 3 and minus 5, and then what we have 3 and minus 5 and minus 1 and 2. Okay, so these two matrices if you multiply, you will get the identity matrix. If you are getting the identity matrix, then the answer which you found over here is correct. Okay, you can verify that. So the row into this column, if you multiply, you get 6 and 5 and minus 1 becomes minus 5. That is only one element. And again this row, this column becomes minus 10 for 2 into minus 5, and this one is plus 10. Correct? And this row, this column becomes 3 minus 3, and this row, this column becomes minus 5 and plus 6. Correct? So you can check the answer now. 6 minus 5 is 1, and this is 0, this is 0, and this is 1. So you got identity matrix. That means your answer is correct. Okay, are you able to understand, children? And it's very easy only about the elementary transformation, and by using elementary transformation, how to find out the inverse we have seen. Okay, then how to find out the inverse of a matrix by using 3 cross 3, right? 3 rows and 3 column matrix that we are going to see in the next session, right? Thank you.